So this is the one that I left in the back of my '89 Corvette one day in the summer and got melted. So I decided to use the parts out of that. That's why I was having a little bit of struggle with some of the switches in the previous video. They were used. Not that this one had been used very much. It hadn't. And I also used some of the wire harnesses out of it. So when I start to wire them, I usually use or do the negative circuit first. So I make my own diagrams just on graph paper. That's how I've been doing it now. Eventually, I'll get them on a computer when I find a program I like and I learn how to do that. So we're just going to do the negative circuit for the switches so that light will work on the switches. You can see I've already got this made up, but I'll show you how I make that. I just take flag terminals and drill a hole in them so the wire can pass all the way through. So I'm using the blue ones, that way the insulator will fit through there easily. You can see there now the wire will pass through there. I've used solid and stranded. It's probably easier with solid wire. I'm demoing here with a stranded wire. So I just use a red one at the end, the first or last one, however you want to look at it. So that just gets a red flag. And then I would line them up with the switches to get my distance. And then just go all the way across. So you can see there I strip back enough wire so I make sure it gets a good contact. So I'm just trying to get it lined up, get them crimped. And I'll just show the process one more time. So you can feed the wire in, figure out your distance. I put a mark on it where I want to strip the wire back. And then just work that insulator all the way off there. You know, expose enough of it so you can crimp it. And that's how I made the jumpers. I used the flags to try to save a little space in the box. I just got used to doing it with one version of the box I made, so I keep doing it. And then you just install them across the negative part of the switch. So we're going to do the same thing across the power for the input power for those switches. So the diagram here is showing, you can see the 4 switches there in the middle with the jumpers. We're only going to power those 4 switches. The other 2 switches get powered differently. So once again, I already had that one made up, so we're just going to go across those first 4. And those receive power off what I call the main switch. So I put it on the bottom terminal so we can go position 1. That supplies power to that bottom terminal and then across to the switches. Here I'm just installing the LED light. So I went back and made sure I turned them because they have little slots in them so that the negative wire would be on one side. So they were all uniform. So there's different relays I use to cut off power to different circuits. So they only work in certain positions. That relay board there, I'll post a video on how I made that board, and that is to turn off power to those LED lights. And I'm just trying to clean it up a little bit. This will actually change a little bit how I have those connected. And that's the negative side of the LED lights for the fuse indicators. And then the meters need power also. I really like using the Wagos for this. Wire nuts and other things, they were a pain. Wagos work way better when I need to parallel these circuits. So I did combine a lot of those circuits together. The load is very small, so I'm not too worried about the load. And like I said, I've got a bunch made up like this that I've been using for, years. So those other two relays I mounted earlier, they need negative circuits also, so that's what's hooking up there. So I wasn't able to reuse all the wiring out of the other box, so some of it's going to be new wiring. That's a 12 gauge jumper wire that we will discuss more later. So a little review of what we just did. These are the switches. This is the top half of the box, bottom half of the box. So these just get paralleled all the way across because all the switches have lights in them. So that's our negative circuit, goes to that Wago there. And then the switch positives were next. So these are just the first 4 switches. So your right turn, left turn, your marker lights, and the brake. Those are going to only get powered when we're in position 1 on this, what I call the main switch. Okay, then we have, these are the LED lights here. They correspond to each one of these circuits. Those get tied to the Wago. These are the fuse indicators. So if the fuse blows, one of these will go out, so you know which fuse blew. They're hard to see otherwise. So those go to that Wago also. And then the meters, they're going to go into that Wago. And these 2 relays, this one we'll talk about more later. That goes to there. This is the one that turns on and off these LEDs, and that needs negative power there also. So this is for the relays that are in here that aren't represented. And then we have the jumper, which was this circuit here. See, it's going to jumper down to the bottom of the box. So I'm just going to confirm here, which is my common post, my normally open and normally closed post for this relay. This relay here controls the LED lights. So in the 0 position of the main switch, those lights will work. But anytime we push position 1 or position 2, then those lights will be taken out of the circuit. And so here I'm just connecting them. We want them on the closed portion of this circuit. So it doesn't matter if it goes on the common or the closed. Will matter later when we connect the second wire though. We have to make sure we match up the brake wire, the running light wire, the left and right turns. Those will matter. So I take those really small wires from the LEDs and I fold them in half, make them a little bit thicker so the terminal has more to grab onto. And I'm just cleaning it up a little bit. It's still going to be a rat's nest at the end, but I try to clean up as many circuits as I can. So in review, what we did here, these are the positive side of the LEDs. Your marker, left turn, right turn, your backup. So ignore that. There, that's a mistake. That's actually the positive side, triggering those relays that are on there. This is representing the negative side. And then you have your common, normally closed and normally open. So right now, this would actually be going all the way through to the light. So if we had this plugged into the vehicle, turn on the left turn, it would go from here through the closed switch to the light. So we could see that light flashing. Goes the same with all the rest. So you can see I have them tied in at the 7-way. So this would be going out to the different flashers or relays. And then these are tied into the LEDs. Now we're going to do a little bit of the positive circuit, upper right hand of the diagram. We're going to supply power to the meters. And then these little jumpers are going to go from the Wago to the fuses. So I just did it this way. To me, it seemed easier than trying to jump between each fuse. Just go from the Wago to the one side of the fuse. So in review, we're tying in this portion here, this top right of the diagram, where we have our fuses. We have the input side of the fuses, the output side of the fuses. Those just tied into the Wago. It's our positive Wago right here. And then the amp meters tied into that Wago also. And later on, we'll be putting in another jumper that goes from the top part of the box to the bottom part of the box. And this is where you're going to get your power from. So either from your auxiliary power or from the 7-way. So the 7-way goes through here, up into here. So I'm going to work on the auxiliary circuit or the backup light circuit. It's getting its own power. So if I tied that in with left, right turn and the marker light, I was having an issue with that circuit overloading with the size fuse I wanted to use so I could keep it sensitive enough to detect shorts. So it gets its own circuit because not all trailers have a backup light either. So you can see it's going to go from its own fuse to the center part of the switch, which is going to be our input. maneuver it through there a little bit and connect it to that switch. That's our input. Then the output that's going to go to the 7-way socket itself. You'll see these all have jumpers on them. So the other one is the LED light. So if I wanted to test the 7-way on a vehicle and see if that backup light comes on, that's what this is doing right here. So review of the auxiliary or backup circuit. You get your fuse power here. So previously we saw we had power coming from this way over to here, goes through the fuse. This gets tied in with the LED. So if this fuse were to open, this LED would go out. This circuit would not work. But then that goes to the center part of this switch here. So when we turn on that switch, it's going to feed power to the center post here. So that circuit is all on its own. It doesn't always get used. So that's also tied from here going up to the LED light control board here. All right, that's it for video 2. Video 3 obviously will be next. We'll do some more wiring, and thanks for watching.